guys, welcome back to Algebra 1. We're looking at our third lesson of this unit, and so let's just go ahead and get started. Our objectives for today are to be able to write equations in a third form called standard form, and then when we have equations in standard form, to be able to use that to find x and y intercepts. Now let's just review a little bit, before we get to that slide, let's review a little bit what we have already learned. We've talked about two other forms before, the first one being slope-intercept, which says y equals mx plus b. And slope-intercept is really good for graphing because we can start at the y-intercept and then follow the slope. We use slope when we use slope-intercept form when we're given either the slope and the y-intercept or a graph. That's when we want to write equations in slope-intercept form. However, this is kind of our standard form that we go back to, the one that we like. And so even when we use these other forms, point slope and standard form, oftentimes we algebraically manipulate those equations to get it back to slope-intercept form. The second one that we talked about last time was point slope form, which says y minus y1 is equal to m times x minus x1. And this is kind of that intermediary equation. We use this when we're given a slope and a point or two separate points. We have to find the slope first. But oftentimes we start here and then we change it to slope-intercept form. Finally, I just want to remind us of how to find slope. We find slope by taking y2 minus y1 over x2 minus x1. Remember, it's wise to put the y's on top, and that just helps us when we're given 2 points to find the slope. So I want to start with kind of a thinking problem, and I know it's kind of a little bit cut off the screen here, but we've got somebody making a playlist of 24 songs for a party. This person prefers country and rock music, and he's going to build his playlist off of those two types of songs. So I want everybody to think right now of what is one combination that he could choose. For instance, he could choose 4 country songs and 20 rock songs. All right, so let's just plot a few of those ideas. So we said, if I call this bottom line our country songs and the y-axis are rock songs, then like I said, the example I gave, he could choose 4 country and 20 rock songs. Or he could choose 10 country and 14 rock songs. Or maybe he chooses 20 country and only 4 rock songs. Is it possible that he could choose 14 country and 10 rock songs? If you'll notice, all of these combinations begin to form a straight line. And any point on this line will be a solution to this problem. Guys, that's what a line is. A line is a collection of points that all make an equation, a linear equation, true. There's lots of different answers. And so now that I have this line, now I can begin looking and saying, oh, I see a point right here. It looks like this point of 6 and 18 would be a good combination of songs. And so I can use that line now to determine other meaningful points. All right, so we've reviewed already slope-intercept form, y equals mx plus b. Point slope form, y minus y1 is equal to m times x minus x1. And then finally, we're going to look at standard form today. And standard form is going to look a little bit different than these two. It's going to say ax plus by is equal to c. A, b, and c are all going to be integers. And we can't have a and b both being 0 at the same time. So when would we use standard form? Because we're most used to using slope-intercept. Point slope is a nice form to get us there if we're given a point and a slope or 2 points. So when might we use standard form? Well, most of the time we use standard form when we're given a word problem that looks something like this. It says Hannah is going to spend $150 on music festival tickets. She can buy 2 types of seats. Reserve seat tickets cost $25 and general admission tickets cost $10. So how could we represent this situation with a linear equation? So first of all, what I'm going to look at is I'm looking for a total amount of money or a total amount of whatever, and then I'm looking for 2 specific situations. Those 2 specific situations are going to be represented by variables. So a reserved seat, I'm going to say X stands for the number of reserved seats that I would purchase. And I'm going to say Y would stand for the number of general admission tickets. And if you'll really consider this situation, there's more than one possibility of how she could split up her money. And so that's why we're going to write an equation so that we can look at all of the different possibilities. So I know that her reserve seat tickets are going to cost $25. So I'm going to say 25 times however many reserve seat tickets she buys. And then her general admission tickets cost $10. So I'm going to add $10 times however many general admission tickets cost. And then I know she's going to spend $150 on tickets. Guys, there is my equation, linear equation in standard form. So I looked at the 2 possibilities of what she could buy, reserve tickets or general admission, and then I made sure that I put the cost of each of those with that variable in order to get my total cost. So how is this helpful? Well, same problem. Hannah's going to spend that $150 on music tickets. Her reserve tickets cost $25. Her general admission tickets cost $10. I want to know what kind of information does this give me that slope-intercept form does not. So I'm going to rewrite the equation right up here. We said it was 25x plus 10y is equal to $150. Now looking at this versus slope-intercept form, I don't see a slope here. There's no m in this equation. It doesn't tell me a y-intercept just looking at it. But what it does allow me to do very simply is it allows me to find the intercepts. What do I mean by intercepts? It allows me to very quickly find where this line is going to cross the x-axis and the y-axis. So just like that problem that we were doing with the country music and rock music, that situation formed a line like this. This is going to allow me to find where her line crosses the y-intercept and where her line crosses the x-intercept. Now, the way that we do this, if I'm going to find the x-intercept, what I'm going to do is I'm going to start by letting the y be 0. Now, let me explain to you why we would do that. Over here, think about any point that's here on the x-axis. If I were to name any of these points on the x-axis, for instance, this would be the point 1, 0. This one out here would be the point 5, 0. This one out here would be the point 8, 0. Do you notice how the y value is always 0? And that's always going to be true. If I'm crossing the x-axis, my y value will be 0. So what I'm going to do in my equation is I'm going to replace the y with a 0. So I get 25x plus 10, oh, there's my y, so I'm replacing it with a 0, is equal to 150. Now 10 times 0, that's just a 0. So now I have 25x is equal to 150, and I can quickly divide by 25 and get an answer of x equals 6. And so what that tells me is that my point out here, where my line crosses the x-axis, is going to happen at 6, 0. All right, now let's find the y-intercept. Anyone have an idea what to do here? Just like before over here, if I'm finding a point on the y-intercept, if we name any of these points out here on the y-intercept, we would notice that they all have a 0 in the x position. And so just like over here, we're going to let x be 0. So I'm going to rewrite my equation, 25 times 0 this time, plus 10 times y is equal to 150. 25 times 0, that just becomes a 0. So now I have 10y is equal to 150. I can divide each side by 10, and I get y is equal to 15. So what that tells me is I'm going to cross up here at the point 15. Now, let's really dive into what this means. What this means over here is she could buy, for her $150, she could buy 6 reserve seat tickets and 0 general admission. Another option that she has is she could come up here and buy 0 reserve seats and 15 general admission tickets. All of these points in between talk about the other possibilities that she could buy. Now, in this case, if I want to spend exactly $150, I may not be able to use every combination because some of these will be parts of numbers. But it allows me to see the other opportunities that I have. Now, the second question on this page says this equation, y equals negative 2.5x plus 15, and 25x plus 10y equals 150 are the exact same equation. So how did they get there? Because I have standard form and I have slope-intercept form. Well, we know how to solve equations for variables, and so we can take this standard form equation. If we wanted it in slope-intercept form, we can move things around to isolate the y. So for instance, I can move this whole term, 25x, to the other side by subtracting 25x. When I do that, I end up with 10y is equal to, and I'm going to rewrite the order here. I'm going to put the negative 25x first, and then the positive 150, just because slope-intercept form has the x term first. All right, y is not quite by itself, so I'm going to divide by 10, and over here I'm going to divide by 10. And if you'll notice, I'm dividing the whole side by 10. So 10 divided by 10 here gives me a y, and then I'm going to divide each portion here by 10. So negative 25 divided by 10 would be negative 2.5x, and 150 divided by 10 gets me that answer of 15. That's how we see that that equation is the same as this equation. So, is it easier to find the x-intercept using standard form or slope-intercept form? I would say probably standard form is easier to find the x-intercept. What if I want to find the y-intercept though? Is it easier to use the standard form or slope-intercept? You know, it's not so hard to find it using standard form. However, slope-intercept form, remember, the y-intercept is part of the problem. So it's right there in front of us. All right. The next problem, they give us the equation. I see that it's in standard form because my x and my y are on the same side of the equation, and they just want me to graph this. So I've got two options here. Option number one is I can manipulate this to get it into slope-intercept form. If that's what I'm most comfortable with, I can absolutely do that. My second option, though, is I can use what I just learned finding the x and y intercepts and use those to plot the graph. So let me show you both ways this time, and then you can choose what you like best. All right, so my first one, I'm going to find the intercepts. So finding the intercepts, remember if I'm trying to find the x-intercept, I'm going to let y be 0. So I've got 3x minus 2 times 0 is equal to 9. 2 times 0 just cancels out, and so I've got 3x is equal to 9, and I'm going to divide each side by 3 and get x is equal to 3. So what that tells me, I'm going to come over here to my graph. What that tells me is it's going to cross the x-axis over here at 3. All right, now let's find the y-intercept. So if I'm looking for the y-intercept, I'm going to let x be 0, the opposite variable. And so now I've got 3 times 0 minus 2 times y is equal to 9. 3 times 0, that cancels out. So I have negative 2y is equal to 9. And if I divide by negative 2, I get y is equal to negative 4.5. So what that tells me is it's going to cross the y-axis at negative 4.5. 2 points is enough to make a line, so now I can just connect those 2 points, and there is my line. If you prefer, you can manipulate the equation to get it into slope-intercept form. So to do that, I would have 3x minus 2y is equal to 9. Goal is to get y by itself, so I'm going to move the x term to the other side of the equation and be left with negative 2y is equal to negative 3x plus 9. Then I'm going to divide by negative 2 and get y is equal to, remember I divide both parts, so negative 3 divided by negative 2, that's going to turn to a positive 3 halves x, and 9 divided by a negative 2 is negative 4.5. If I were graphing this, I would begin at negative 4.5, and then I would rise 3, 1, 2, 3, and run 2, and I would just make sure that that looks like it's reasonable that it's on that line. Would you go ahead and pause the video for a second and work on question number 2? Using one of those two methods, graph 4x plus 5y is equal to 10. So I've used the x and y-intercept method and found the x-intercept to be at 2.5, the y-intercept to be at 2. So if I'm going to graph those, x-intercept is at 2.5, y-intercept is at 2. My graph would look something like this. If you chose to use the other method of getting it into slope-intercept form, we're going to start by subtracting 4x from each side. And then dividing by 5 on each side. And I get an equation of negative 4/5 x plus 2. So I would start at 2, and then I'd go down 1, 2, 3, 4, and over 5, 1, 2, 3, 4, 5, and just make sure that that looks reasonable, that it's on my line. And both of those methods look pretty good. All right, so let's try one more. I'd like for you to go ahead and write the standard form equation for this problem. Tamara is making a trail mix. She has $40 to spend on a mixture of almonds and cashews. She wants about the same number or amount of cashews as almonds. How can she determine how many pounds of each kind of nut to buy? Notice we're looking not only for a total, but also for each individual price, and those are here on the picture. So I'm going to start by saying X is the amount of almonds that I'm going to purchase, and Y would be the amount of cashews that I'm going to purchase. So I could write my equation of 8 times x plus 10 times y is equal to the $40 that she's going to spend. Remembering here, I can have lots of different possibilities. So I could start by finding my x and y intercepts and then work towards something in between each one of those. Or I can just look at the different possibilities of what she wants to purchase. All right, there are two special cases with this. What about those lines that don't have a slant, that are either straight horizontal lines or straight vertical lines? We need to talk about those. So the first thing I want us to do is I want us to determine how we would go about solving 3a and 3b. Guys, these really are just simple equations. So if I have 3y is equal to negative 18, I would just start by dividing each side by 3. And I end up with y is equal to negative 6. Part B, I would simply divide each side by 4. And I would get x is equal to 3. That's all fine and good. But now, how do I graph those things? Well, what this is really saying is that every point I plot needs to have a y value of negative 6. So let's think about that. Y value is here, and so I'm going to come down here to the y value of negative 6, and I'm going to plot a point. Doesn't, though, this point also have a y value of negative 6? This point would be 2, negative 6. This point would be 3, negative 6. If you'll see, I'm starting to make a line. It's a horizontal line that goes through the negative 6 on y. Okay, let's look at the second possibility. X equals 3. If I come over here to the 3 on x, that's where x equals 3. But doesn't x also equal 3 here at 3, 1, and at 3, 2, and at negative, or at 3, negative 1? This one makes a vertical line. Guys, if you can just remember that y's by itself will make a horizontal line and x's by itself will make a vertical line, I think it will make your job a little bit easier. One thing that some students and I have thought about in the past is if you flip that y upside down, it kind of looks like a letter H, a lowercase letter h. And so that helps me remember y is the horizontal line. All right, that's it for today. So would you take some time now and look at Pearson 2.3 assignment? If you've got any questions, make sure you're checking in with Mr. Jordan or Mrs. Sanders, either one. And we want to help you. We want you to do well. This is a very quick unit, so we've only got one lesson left. So make sure you're keeping up with your homework. And if you've got questions, you're stopping in and checking in. Thanks a lot, guys. Have a great day, and I'll talk to you later.